you'll notice that its right leg is actually missing. And if you now play video 2-3, please, you'll see that we used an evolutionary algorithm to infer what had gone wrong, and we now, or the robot now, re-evolves a qualitatively different way of moving. This particular locomotion strategy is completely different from the first one that you saw. So that's just a very brief demonstration of the idea of resiliency. The robot learns to move in a particular way, it experiences some unanticipated situation, realizes that its current way of doing things is no longer appropriate, and generates a qualitatively new behavior. So in the remaining few minutes, I'm going to show you some more details of this work. Obviously, I don't have time to go into all the details, so if you're interested in this particular project or some other evolutionary robotics projects, please you can just Google my name and find my webpage. There are papers there that describe this work in more detail, as well as additional videos. So changing to slide 3 now, I'm going to walk you through some of the main points of the experiment that you just saw. So our physical robot begins with some knowledge about its own body. So it knows that it's made up of 9 parts, but not how these parts are put together, and most importantly, whether or not some of these pieces are missing, which is important, obviously, if this robot incurs physical damage. So moving ahead to slide 4 now, if you can play video 4. You'll see at the beginning of this experiment, our robot begins by performing a gentle action, which is this rocking motion, okay? You can now go to slide number 5 and start the simulation video that you find there. So our robot has moved slightly and has now sensed that its main body has tilted slightly. The robot now starts an evolutionary algorithm which, like the block pushers, is searching the space of body plans. And you can see that the body plans it's considering here are how to connect all of these 9 parts. Now, at the beginning of this experiment, our robot doesn't have enough sensor motor experience to be able to find a correct model to describe itself. So moving on to slide 6 and starting video 6, our robot now goes back to the physical world and performs a different action. So now you can see our robot rocks slightly to the left. If you move to slide 7 and play video 7, you'll see that the robot now restarts the evolutionary algorithm and searches the space of all body plans. And you'll see in this particular video, it suddenly discovers through the evolutionary process that it's composed of these 4 legs. Okay, skipping ahead to slide number 8, if you can now play video 8. Oh, I think we've missed a video there. Is that video 8? I might have sent you the wrong video by mistake. If you can play video 8 for me, that would be great. That's fine. Let's carry on with that video. This is about 2 hours into the experiment, where the robot has now, as you can see, discovered the correct body plan. So in essence, what our robot is doing is alternating between physical experimentation, learning about the sensor motor coordination of its own body, and using those experiences or grounding the evolution of self models, like the one that you see here, in these sensor motor abilities. So moving on to slide 9, moving on to slide 10, and if you can play video 10 for me. Okay, so in video 10, you can see now that the robot has evolved a self-model and is now using a second evolutionary algorithm to evolve a locomotion strategy. So basically the robot is saying, I know that I have 4 legs, and using an evolutionary algorithm, I've discovered this particular way of moving. So now moving on to slide 11, now that it has this physical gate, now it has evolved this gate, it's going to try it out on the physical machine. So if you can play video 11 for me now. So this is the gate that you saw before. So through this process where the robot is actually using two different evolutionary algorithms, one to create a self-model and a second evolutionary algorithm to evolve a locomotion pattern using that self-model, a robot can teach itself to walk